The next presentation here by Ollie and Chris from WSP and Sabora around the marine autonomy opportunity.
Thank you, Richard. So the beginning of this talk is just to introduce a piece of work that we've done, and then I'll hand over to my colleague Ollie, who will speak about areas outside of maritime. The work that I'm referring to is actually in the brochure that you see lying around, so by all means check out the summary there. The work was commissioned by Plymouth City Council, MHCLG and Plymouth and South Devon Freeport. We were asked to look at the opportunities for marine autonomy both in the UK and nationally. What I really want to focus on here is the visual presentation of the slide rather than the exact content. I want to drill home that it's about dual opportunities. It's about the crossover between different sectors, be that defence, offshore wind or other uses of the seabed, and data collection represented by a satellite there because of the commonly stated fact that we know more about the surface of Mars than we do about our oceans. Marine autonomy offers a big opportunity to change that. Barriers, I'm not going to focus on the individual barriers here. As I said, you can check on the brochure. What I wanted to say is that it's not about barriers that need to be unpicked in order for growth. It's that there's already a build-up, there's a holding back of the opportunities. There's a lot of frustration from the industry about the progress that hasn't been made, that could have been made. And recommendations. Again, won't pick on the individual items here, but just wanted to pull out that because of the nature of the sectors that are of greatest interest to marine autonomy, you can look at the commissioning or the specification of capabilities within marine autonomy and then demonstrating that you're meeting those capabilities. It's very important for winning the contract, be it defence or energy companies. You have to be able to prove what you're doing is doing what you said you'd do. And at that point, I'd like to hand over to Ollie.
Chris, good afternoon everyone. My name is Ollie Teal. I am the Global Digital Lead for Intelligent Mobility at WSP. And my mission over the next 10 minutes is to not talk about maritime autonomy, actually, is talk about autonomy in transport sectors outside of maritime and talk about some of the enablers we're seeing to autonomy within those sectors, in the hope that some of those are of interest and of relevance to the maritime sector. Or at the very least, there's something slightly different from everything else we're seeing at the trade show today. So I will, well, first of all, a bit of a context really. Most people, or some people may remember this gentleman on the left, Philip Hammond, the ex-Chancellor of the Exchequer. He announced back in 2017 that he was fully self-driving vehicles on UK roads by 2021. Oh, okay. So the mic's playing up slightly, but I'll keep going in the hope that it fixes itself. Okay. So what is? There we go. A little bit better. So clearly that didn't happen, but a lot of other. Sorry, keeps cutting it out in and out.
Do you want to switch to mine?
Yeah, that might be easier actually to switch. Sorry, just take off the switch over. Right, hello. Okay, I think that might be a bit better. So, as I was saying, the aspiration was to see fully self-driving vehicles in the UK by 2021. But a lot of things happened between 2017 and 2021 that we weren't expecting, if you remember. Sorry, I'll go back slightly. So, but what we are seeing now is the likes of Waymo starting to roll out, or really seriously thinking about rolling out autonomous robotaxis in London this year. And what does this tell us? Well, first of all, some of these things are very confident. If you have government backing, funding, aspirations to deploy autonomy, there's a lot of complexities behind that, which mean it might not happen the way that you expect it to happen. But actually, I would say that what happened between 2017 and 2026 was a whole load of activity was kicked off by this government aspiration, which then led to us being in a position where we are now ready to roll out those sorts of things. And I'm going to talk a bit about some of the enablers that needed to be in place. Yeah, exactly. Yeah, what's going on? Okay, I'll keep going. So I won't read through all of these, but I'm going to talk about each of these enablers in turn, and talk about some of the things that we're seeing in different sectors outside of maritime.
It's not putting in the pocket.
Why they are also important and why they need to be in place. So, first of all, the technology. So clearly, if you are developing an autonomous service or operation, if you don't have an autonomous product or vessel that works, then your service isn't going anywhere. But the tagline here is automation doesn't mature as a vehicle, it matures as a service. So I mentioned Waymo. They're successfully running autonomous vehicle operations across cities in the United States. But even where they are doing that, they are hitting a lot of challenges and roadblocks. So you may have seen in the news recently they're getting pushback from New York unions, for example, about rolling out autonomous vehicles in Manhattan. And even where they are running those autonomous services, they're hitting unexpected snags in their service. So in Atlanta, for example, Waymo are having to pay DoorDash gig workers to close the doors of autonomous robo-taxis that previous occupants have left open. These are elements of a service that probably weren't considered when they were developing the autonomous vehicle itself. So it's something that needs to be considered when you're thinking about it. It's not just about the vehicle; it's about the service as a whole. And linked to that are business models. Now, this may seem relatively straightforward, but you'd be surprised how often this is the biggest blocker to an autonomous operation being viable. You know, where is the value, who benefits, and who pays? And the picture you can see here is from Rio Tinto autonomous mining operations in Western Australia. And this is a great example of where those things are very clear-cut, very apparent. So the value to Rio Tinto is clearly in the efficiencies and the safety of their operations in mining in these enormous open-cast mines in Western Australia. They benefit through increased margins and profits, and they ultimately pay for the upfront cost of that technology and reap the benefits later. Contrast that, for example, with the aspirations to replace public sector bus operations in cities with mass transit autonomous vehicles. Now, bus operations in most parts of the world are subsidised, so you've got a complicated system there where you are the taxpayer is paying some of that fee, ticket price covers some of the other elements of it, and you're trying to replace that with a service that is high tech, so therefore capital investment intensive, and you may not see those returns for many years. It's a much more difficult business model to get right. So this is a fundamental aspect of how do you run a successful autonomous operation. Standards and regulations. That image on the left, or the concept on the left, is very, very well known, very widespread. This is the SAE levels of automation in autonomous driving. It's probably one of the most well-known things to come out of the autonomy debate. And the reason I highlight it, for those of you who are aware, it defines the levels of automation between zero, no automation, all the way to full automation, and this interesting part in between of moving from conditional automation to high automation, where humans are either in control or not in control of autonomous vehicles. And the reason this is really important, I think, is it gives people something to talk about, definitions to talk about when they are talking about autonomy. It gives people something to argue around. And importantly, it gives businesses and investors something to talk about when they say, where are they positioning their business? So until very recently, a lot of the automotive manufacturers, mainstream automotive manufacturers, were going all in on level 3, this sort of conditional automation, or level 3++, however they wanted to term it, which is essentially humans are always in control, but they're getting ever more advanced autonomous systems, ADAS systems, which are augmenting their capability. Whereas other manufacturers went all in on high automation or full automation, and they were saying, no, we're going to be fully autonomous, robo-taxi type models. They're very different environments, they're very different models to take as a business. And those lines are getting increasingly blurred as the technology advances. So So the tagline here is that regulations don't certify autonomy, but they certify bounded autonomy with defined responsibilities. And a good example of this is the Autonomous Vehicle Act 2024, which was, again, going back to my context set, was sparked off many years ago and has come into law now. And this separates two things. So it separates out the certification of the vehicles, a type approval process in Europe, and certification of the autonomous service, as in the operations through a self-driving test. And the details of that are being worked out through secondary legislation at the moment. But that's important because it then talks about the self-driving test is around how does that autonomous service work within its operational design domain. And I'll get on to what operational design domain factor looks like just shortly. User acceptance. Now this is something we're seeing played out all over the world at the moment. Sadly, we're still seeing thousands of people seriously injured or killed on roads, but it barely makes the headlines. But if you have an autonomous vehicle which crashes and causes a fatality, that's big news. And there's many reasons for that, but one of the biggest ones is trust. When you are getting into an autonomous vehicle, you're putting your trust in a machine. Now you could say every time you get into a taxi, you're putting your trust in the driver of that taxi. But as humans, we are much more comfortable putting our trust in another human than we are putting it in a machine. So the trust in this space is earned through operations, through assurance, and through humans in the loop. So the picture you can see here is the Dubai Metro. That's been running autonomously since about 2009. When I was over there a couple of years ago for the ITS World Congress, I got talking to some of the locals who were saying for the first year or so, they had a human driver there, safety driver, who had very little to do really, other than just to provide a bit of assurance, a bit of kind of trust really, that there is somebody here that this system could fall back on, somebody to talk to about when people are a bit worried about it. After a year or so of safe operation, that driver was removed, and that's been running autonomously ever since. He now carries about 275 million passengers every year. Operational design domain, I mentioned, it's not a particularly sexy term, but it is very important. This is about defining the box in which your autonomous service or operation fits within. Define that box before you scale the ambition. And a good way of illustrating this is the famous Heathrow pods. Their operational design domain is designed perfectly for that. It's a fixed bit of infrastructure. The vehicles take passengers from the car park to the airport terminal. It's safe speeds. There's very few unexpected things that will occur within that journey. It's predictable behaviours and predictable patterns. Now contrast that with the robotaxi model I talked about earlier, where you're putting autonomous vehicles into environments where you have pedestrians, you have cyclists, you have people on horses, you have people walking randomly into the road, you have weather conditions to deal with, all of that sort of stuff. It's a much more complex environment, it's a different operational design domain that needs to be considered and also tested and certified against. And finally, probably most importantly, assurance and safety. So the big question here is how do you prove that your autonomous service or operation is safe enough both today and will be safe enough in the future? And a good example of where that's had to be done is in the aviation sector. Now, the aviation sector has come under a lot of scrutiny recently from a safety perspective. Now, but my view is that's mainly to do with the safety culture at certain aircraft manufacturers rather than the autonomous systems and how those are assured. So what they've done in the aviation sector is have a multi-layered safety assurance approach to how they do this. And it starts with hazard-based certification, hazard-based assurance, where you basically say, okay, you've got autonomous system which may be to do with taking off, in-flight, landing, etc. What happens if it fails? And how serious is it if that fails? That then gives you a design assurance level that you need to certify to. You then have software standards for any airborne software that needs to be met. You then have multi-layered redundancies, so the triplicates or quadruplicates of those really key systems, depending on how important they are, so that you have fallbacks. And finally, you have operational constraints on those systems. So if they start operating outside of what they were designed to do, the operational design domain, they fall back to other systems and ultimately fall back to a pilot. So in the aviation sector, there's a clear distinction between autonomous task-oriented autonomous systems and pilotless aircraft. Those are two different things. And that's how they've proven that these are safe. They test them, and then they've gone on to use them. And most modern aircraft have a range of autonomous systems now that are being used. So I appreciate that was a very quick rattle through, but my summary really is autonomy in transport is complex, but it is very much achievable, has been achieved in many sectors across the world. And the enablers that I talked about there are key factors that need to be in place, in my mind, to make those autonomous operations successful. So happy to take questions, talk to anybody here. I'll be here for the rest of the day. Thank you very much.